Hey everyone, my name is Sean, and in this project I built a model to predict the net hourly electrical energy output represented by PE for a combined cycle power plant using 4 ambient variables. These variables include temperature, exhaust vacuum, ambient pressure, and relative humidity. This is a supervised regression problem, and I've chosen to evaluate the model using root mean squared error and R squared for explained variance. The data set contains about 9,568 hourly observations of those 4 features, plus the target PE. And I used all 4 ambient variables as features because they're physically linked to the turbine efficiency and heat exchange. I chose to split the data into 70% train, 15% validation, and 15% test. And for model selection, I used 5-fold cross-validation on the training set. The validation set I chose to hold out for comparing candidates, and the test set would be used only once at the end for an unbiased estimate. I compared 2 model families, linear regression being the first, for an interpretable baseline and a good check of linear signal, as well as a random forest regressor to capture nonlinearities and feature interactions with minimal pre-processing. I tuned the random forest with a grid search CV for hyperparameter tuning, and I ultimately chose to select the final model using the lowest validation RMSE. I ran a Python script for this modeling project, and here you can see that the results of the Python script are listed here. And the way I interpret this data is that the linear regression model provided a strong baseline, explaining about 93% of the variance, with roughly 4.5 megawatts error. But the random forest improved accuracy significantly, reducing error to roughly 3.2 megawatts and explaining 97% of the variance, making it the clear and final choice. In conclusion, the final model achieved strong performance with high R squared and low RMSE, demonstrating that the ambient conditions are reliable predictors of energy output in a combined cycle power plant. Just going through some of the documents, this is the provided data file through the course that was used on this machine learning model. Here I have my Python script, which essentially loads the data, splits the data into the training, validation, and test sets, compares the linear regression versus this random forest using a 5-fold cross-validation method, tunes the random forest hyperparameters using grid search CV, evaluates the selected model on the held out test set, and saves a predicted versus actual plot for the test set. Here's my terminal on my Mac showing the execution of the Python script, as well as the results, which I have shown previously, as well as the feature importances, highlighting the significance of temperature and exhaust vacuum features. And lastly, here is the plot graph showing the predicted versus actual on the test set for the random forest model. Thanks everyone for watching. Appreciate it, and hope you have a good day.